This lesson is on arc length and area of a shaded region or area of a sector. So first we're going to talk about what arc length actually is. If you recall in our last lesson, we learned about arcs being the part of the circle that's on the outside, that's on the edge, and we were measuring them in degrees. So however many degrees the angle was, the central angle that formed it, that's how many degrees the arc was. But now we're going to actually talk about length, right? We normally measure things in feet or inches or whatever that is. So when we're talking about an arc length, we're talking about how long it actually is. Right? It's the distance between the endpoints along an arc measure, which means it is a portion of the circumference. So we do need to know that circumference, we already talked about it before, is 2 pi r, right? So now when I'm talking about arc length, I'm talking about a portion of the circle, or how many degrees the arc is out of the 360 that an entire circle is going to equal that arc's length over the entire circumference. A lot of times the length will be x. That's what we're looking for if it asks to find the arc length. And circumference we can replace with 2 pi r or pi d, depending on what information we're given or what we're finding. So in our first example here, they want us to find the length of arc zy. All right, so that's this arc right here, which I know is 130 degrees. Right, that's the central angle that forms it. And this 10, because it's in the center of the diameter, is actually d. It's not r. If it was only over here, if they only put the measurement over here, that would mean it was the radius. But because it was by the center, it is the diameter. So we're going to do degrees over 360 first. So we know that's 130 over the 360. And that's going to equal the arc length, which is find the length, that's going to be x, over the entire circumference. So since I have d, I'm going to use pi d, so that's pi times 10. All right, and this should be much more familiar for us. We have a proportion we're going to solve by cross multiplying. So I'm going to get 360x, and for now I'm going to keep it in terms of pi. So I'm going to have 130 times 10, oops, lost my x there, equals 1300 pi. All right, in case the question asks us specifically for an exact answer, I would want pi to stay as its symbol as opposed to its equivalent. And here I would divide both sides by that 360. So now I have x is, and an exact answer would be 3.61 repeating pi. But I'm okay with giving an approximation, and we're going to round it to the hundredth. And I want to use the actual pi button on my calculator. I know that pi is equivalent to about 3.14, but to be as precise as we can, we're going to use the pi button on our calculators. If you're having any trouble finding that, do a quick Google search of your calculator or send me an email, and I can help you out with that. So when we do 3.61 repeating times pi, we end up with 11.34. And our units in this case will be the same as whatever the units of the diameter were, so that's centimeters. All right, so 11.34 centimeters is the length of arc zy. Try this one, give it a pause, and when you're ready, play again and you can see. All right, so if you did it correctly, you should get an answer of 5.24 inches. Okay? In our next example, we are going to go in a different direction now. We want to find the length of the radius, and we're given the arc length. So this is actually my length, and I'm looking for r, right? R is unknown. So I'm still going to do degrees over 360 first. Degrees is 290 over the 360. And now, instead of putting x up here, I'm going to put the arc length up here. So that's going to be 46.75 over, And I'm looking for the radius, so that tells me I'm going to use 2 pi r. If they asked for the diameter, I'd use pi d. If they just asked for the circumference, I would just use a c. All right, and now I'm going to cross multiply this again. So we get 580 pi r equals, and now the 46.75 times 360 is 16,830. And when I divide both sides, I have to be really, really careful. I'm dividing by the entirety of 580 pi. So when you do this on your calculator, I would use parentheses around your 580 pi, because otherwise it's going to think you're dividing by 580 and then multiplying that answer by pi. So you have to be really careful with this. So when we do this, if we do it correctly, we're going to get r is about 9.24 feet. All right, if you got something different, go back and look at your calculator. Make sure you use the parentheses. If you're having a hard time with that, divide by 580 first, hit equals, and then divide it by pi. Try the next problem, pause until you're done, and when you're ready, play to look at the answer. All right, so if you did this one and you did it correctly using our right parentheses, r would be 20.53 centimeters. All right. So the next thing we're going to talk about is area of a sector. A sector is basically like a slice of the circle. All right. So here we have a sector, right? It's a portion of the circle formed by 2 radii and the arc between them. And really it'd be like a slice of pizza, right? If we cut a whole circle or a whole pizza into different slices, each slice would be its own sector. If I want to find the area of a sector, I'm going to focus on still the degrees out of 360. So we're going to have degrees out of 360. And then that's going to equal the area of the sector. Oh, this is going to be a long one. Area sector over the area of the circle. All right. Same as we were setting up with arc length, except now we're almost always going to be finding the area of the sector, so this will almost always be our x. And down here, we'll either be given the entire area of the circle, or we're going to use the formula pi r squared. So in our first example, we see that this sector has an arc measure, or degree measure, of 135 degrees. So that'll be 135 out of 360. And that's going to equal my area of the sector, x, over, and they're giving me my radius. So I'm going to use pi r squared, so that's going to be pi 6 squared. Make sure when you're cross multiplying, you square the 6 first. So we're going to get 6 squared times the 135 times pi. So I'm going to have 4,860 pi is equal to my 360x. And now I'm going to divide both sides by 360. Again, in case they want an exact answer, I would keep it first as the decimal, 13.5 pi. And now I can turn that into my actual equivalent answer, and that would be 42.41. And since this is an area, we're now going to use centimeters squared. All right. So you're going to go ahead and try the next one. Pause. When you're ready, hit play. All right. If you did it correctly, we'd be at 7.07 inches squared. All right. Moving on. Example 4 is a lot like example 3, but what you'll notice is different in this one is the sector that's shaded is not the one that they tell us is 65 degrees. It's everything else. So I actually need to use the angle here. Since we know a circle is worth 360, I could take the 65 away from 360 degrees and I get 295 degrees over here. And that's now what I'm going to use. Everything else about it is the same. Degrees over 360 equals the area of the sector, which is what we're looking for, over, and they give us r equals 11. So we're going to get pi times 11 squared. All right, cross multiply this. We get 360x equals, and it's going to be a big one, 35,695 pi it's also not even a nice decimal. I'm rounding this decimal, so it's still not exactly exact. 99.15 pi. And now I'll convert that to 311.50 inches squared. So as always, try the next one and pause and come back when you're ready. All right, as long as we remember to take the 36 away from the 360, we should have gotten 282.74 meters squared. Almost done. The last thing we're really going to look at is combining different areas or taking away different areas. So in this problem, we have a rectangular wall that has an entrance cut into it. So we want to paint the wall here, but we're obviously not going to paint the entrance because that's an empty space. So to the nearest square foot, what is the area of the region you need to paint? So we do have this big rectangle here that has dimensions of 36 by, together, 26. So I can find the area of the entire wall, even if I did have that space there, by doing 36 times 26, right? Area is length times width of a rectangle. So we're going to do 36 times 26. And for that, we will get 936. But now I need to take away the parts that are not being painted. So I know that one of the parts that's not being painted is this square here. And I know it's a square because it's 16 long here and 16 long here. So that one, 16 by 16, 256 is my square. Just going to put a box there for square. And then this portion up here is a semicircle, right? It's half of a circle, which means I can find its area by taking half the area of a circle. So that's half of pi r squared. We notice the diameter is 16, which means the radius is 8. So we're going to do half of pi times 8 squared. We're going to make sure to square the 8 before we take a half. So that's 64. Half of 64 is 32. So that's 32 pi, or 100.53 for our semicircle. So now the painted area is going to be the entire shape minus the square minus the semicircle. That's an awful semicircle, but we're going to take it for what it is. So 936 minus 256 minus 100.53 gives us a total of 579.47 square feet. For the last problem for this lesson, same idea, except there's nothing to take away now. We have a farmer who has a field with the shape shown. It's our beautiful heart here. Find the area of the field. So we have a square and 2 semicircles that make one entire circle. So go ahead and pause, give it a try, and when you're ready, come back. All right, you should have gotten a combination of 64 plus 16 pi, which turns into, ooh, that's bad pi, 114.27 meters squared. All right, that's it for the rest of 10.2 and section 11.3.